mx plus c. In our case, it's really mt plus c, okay, because our x variable is really the time variable t. Okay, m is the slope, in this case the average slope, and c is the average intercept. Okay, right, let's go back and take a look at our data. Okay, so in the next column over here you'll see something that I've labeled line data. So go start a new column, label it line data, and then in the very first cell create a formula. Okay, so you're going to go equals, okay, you're going to take this cell, okay, you're going to take that cell which is time. Okay, so you can look at, you can see the formula up here in the formula bar. This, by the way, is called the formula bar. You can see that what I've got is I've got cell C2. Data exclamation mark really means that it's selecting the data from sheet called data. It's selecting the cell C2 and it's multiplying it by m. Remember, my m was the average slope that I computed, okay, earlier. And here's my c, okay, which was my average intercept. Okay, that's my average intercept. This is my average intercept right there. Okay, so go ahead and generate that formula right there. And then what we want to do is we want to replicate this formula in the rest of this column. So go ahead and do Control C, select the rest of the elements in the column and do a Control V, and you've pasted that. So what we've got is now a column that I claim is a line. Okay, well, never assume that things work. Okay, always verify, always check. So in this case, what I want to do is I want to select reference time. This is going to be my x-axis, and line data. Now notice that these are not two contiguous columns, so I just can't go Control select line data. Okay, so I got to go Shift, and then I'm going to hit my select button. Oops, oh my bad. Sorry, that wasn't Shift. It should have been reference time, and then a Control. Hit the Control key and this column here. So the two columns should be highlighted like that. Okay. Again, one more time. Let me correct that. You go select this column first, then hit the Control button and select that. Okay, and you got two non-contiguous columns that have been selected, and you want to go graph that. Okay, so you guys know how to do that. Go chart and do all your stuff. Okay, I'm going to go ahead and show you what my line looks like, or at least what the data I think was a line is. Wow, well, it looks like a line, so I didn't F up anywhere. Okay, so that's good. That's good. Hopefully you get a line as well. Okay, all right, everybody with me on that? Let's go back to the data worksheet. And so we've generated the line data, and going back to temperature M, remember what I told you. I told you that this graph looks like it's a straight line there added to a sinusoid function. So in other words, what I'm saying to you is that what I want to do is remove the straight line part of this function here. Okay, remove it. Okay, so that's kind of called removing a trend. Okay, so there's a linear trend to this, and I'm going to remove that. And what I mean by that is, go back to the data sheet, is generate a new column, give it a label, temperature with removed line. Okay, and then take a look at the formula I've generated in the first cell here. All I've done is I've taken the temperature in this cell, okay, and subtracted this amount from it. So go back again, you can see it's D2, sorry, my bad, it's D2, that's this cell here, okay, minus this cell here, E2. Again, look at your formula bar there. Okay, that's your formula bar. Okay, look at that bar, D2 minus E2. Okay, so I've generated a formula there, and what I want you to do now is copy this formula. So Control C, select the rest of the thingy, Control V, and you've got data where you've removed the linear part to it. Okay, remove the linear part to it. All right, everybody with me? Okay, next, like I told you before, never assume that things are working. Always check. So what do I mean by checking in this instance? Well, I want to see what the result is after I remove the line in it. So what I'm going to do is I'm going to graph this column versus this column. Okay? And you tell me, what do you think you should see? What do you think you should see? Anybody? Okay, well, I hope you thought that you should see this. Whoa, man, that's exciting. Look at that. This looks like a more reasonable sine wave. Still not quite perfect. Still not quite perfect. And you tell me, why do you think it's not quite perfect? Well, the first thing that I see is that the graph is not quite centered about 0. In other words, this height here from there to there is not quite the same as this height from there to there. Not only that, you've got this peak being higher than this peak. Okay? So if it was an ideal sine wave, then this peak should be the same as that. And it should be centered pretty much around the origin. Okay? But this is real world. This is real life. It's not perfect. It's not perfect. So what we've got to do is we've got to come as close to this curve as we possibly can. As we possibly can. It's not going to be perfect, but hey, you can't get perfect real life. Well, if you do, let me know how you get perfect real life. I'd like to jump on that bandwagon and get a perfect life. Okay, so my aim now is to try and come up with an equation to fit this data. It looks like a sine wave, but there's something obviously different about this sine wave than the sine wave that you saw earlier when we did this learning activity. Just look at that, compare that to what you see here. We've already gone through some of the subtle differences, that the peaks are not quite the same. Okay, we've already gone through that. But there's yet one major difference. What is that? Well, if you notice in this real data, the graph of the sine is starting out high and coming down like this. Whereas in our idealized sine, it's going up. So how do we get this thing going down? We've done this, okay? This is the graphing gyrations that we studied in pre-calc. Okay, remember the gyrations of functions? Okay, we've studied this in pre-calc. How do we flip this guy over the x-axis? Okay. Well, the answer should be you stick a negative sign in front of the function. So whatever function that we come up with, instead of being y equals sine t or sine bt, it's going to be y equals negative sine bt. Okay? Right, let's go back to data. And what I'm telling you is that this column here needs to be fitted with a function y equals negative